So my name is Joseph Wilson. I'm going to be presenting on my project dealing with a license plate reader application. First, a little bit about myself. I'm a martial artist, Navy veteran, agile consultant, and now a data scientist. Now, some quick computer vision examples, some of which you'll already be familiar with. Autonomous cars, Instagram filters, parking garages, and deep learning supersampling, or some of you will simply know it as the CSI Enhance. So an overview of my particular project. My data set included 100,000 synthetic license plates, specifically representing the country of Turkey. I first used OpenCV in order to process and segment those images into the individual characters. I then used TensorFlow and Keras in order to read each individual character, and then appended those characters together in order to get a prediction. So we're going to go through the individual image processing steps that I went through. This is an example of the unprocessed license plate. First thing I did was a grayscale in order to reduce the channels down to just a single, black and white. I then applied a thresholding, which is simply I choose a certain lightness. Anything above that brightness is going to become pure white. Anything below that becomes pure black, followed by a couple of other operations such as erosion, blur, and finally contour detection in order to actually target the individual characters. From those targeting boxes, I can then bring out my segmentation. This is where I get my individual characters. So with those characters in place, I can then feed it to my convolutional neural network. For those familiar, this is the overall design, a very simplistic, straightforward model, only reading a license plate. That's how you can keep it so simple. So in this case, we take in that simple character. We apply, in this case, 40 convolutional layers to it. These are just a couple examples of what a convolution will look like to us, followed by a couple downsamplings in order to bring that down in size, make it a lot more performant and fast responding. And then finally, the output. Now, in this case, we only have 30,000 parameters compared to 100 million or so on some of these other models. This is quite sizable. In this case, it's so small you can actually run it off of a web browser. Let's see here. Now, of course, given the project's scope, I'll say, the performance reached 100% accuracy. So given a Turkey license plate, it's going to read it. Now, in this case, each epoch, as it's known, is an iteration through the entire training data set. In this case, that's about 450,000 characters. So it very quickly learned that particular font that the country of Turkey uses. Now, in this case, I was working on developing the full end-to-end machine learning solution. So focusing on that entire data pipeline that can be run right from web browser, as well as the Flask web application. Now, future steps can work on actually developing that CNN to address some of the limitations, such that it can only work for Turkey license plates at this point, and any sort of aspects, rotations, or even noise in the image are not guaranteed to have 100% accuracy. Now, of course, just a quick demo of what the Flask web application looks like, how it kind of works. Okay, you would log on just like any sort of website you would expect. Prompts you to upload a particular license plate. It presents you the original license plate as well as the predicted text. Now, next steps. Okay, now that I've knocked out the Flask web application, I'm going to look towards making a Docker image of all the dependencies, all the software needed to run this. That way I can deploy it onto something like Amazon Web Services or Google Cloud. Create a suite of automated tests for maintainability, and then overall make the model much more rigorous for other countries. Some acknowledgements, and I'll open it up for any further questions.